Yeah, it was interesting. You said that you said it's not going anywhere, and you also mentioned a bit about kind of where it came from because it. The funny thing is, it's not a new technology at all.
No.
It's actually really old.
Yeah.
It's more like something that's gone in and out of fashion, and it's kind of like making a comeback under new names. But it's something that's ultimately been around for a long time under different names, like Cube Analytics, and there are lots of older
True.
technologies as well,
Yeah.
right, that do this. So it's almost an old idea that is having a resurgence with kind of new technologies and products.
I mean, the interesting thing in the data space, there are enough, let's say, old people to point this out all the time. So hey, we already had this in the 90s. So yes, you did. But
Yeah.
but the interesting thing is, I mean, yes, of course. Like, I mean, I guess for a lot of concepts, it's like that concepts are there already for quite some time because, I mean, we will come to this, what kind of challenge it solves. And the challenge was there, I think,
Mhm.
since the beginning. But let's say the way how it's implemented, the way how we use it, this is the stuff that changed over time. So um,
Mhm.
this is why I'm always like a little bit, let's say, hesitant with these kind of people who say, yes, it was already there. So yes, in the end, mathematics is around for, I don't know, 2000 years or so, maybe roughly.
Yeah, but also the underlying tech changed a lot, especially the
Yeah,
warehouse layer.
exactly.
So like we were having to worry a lot about caching and the
Yes.
speed, and a big part of the semantic layer was around performance. And now it's not, because
Yeah.
we get that performance for free with basically this these kind of scalable warehouses that have almost like infinite potential to run queries over huge databases.
Yeah.
We're not stressed now about um, provisioning individual servers and individual databases. And so I think
Exactly.
having stripped that worry away has kind of freed the semantic layer up to be more of a user experience kind of benefit alone, rather
Yeah.
than like this kind of cost efficient performance solution, as well as something that gives you a great UX.
And I think that's a good point. I
Okay,
park
I'm
this.
jumping ahead.
No, I park this for a second. We come to back to this because, like, I think this is like what really makes it important to really point it out. What is
Mhm.
relevant today, and as you said, so it's still relevant. And let's say 10 years ago, it also solved other problems. Which, for example, the whole, let's say, data warehouse technology had other challenges that they had to solve first, and that's why data modeling was maybe has different purposes 10 years ago than it has now, but
Yep.
principle stays the same. Okay, but let's start here. So we have some sources where some data is coming from. Then we have this, let's say, we like database, which is our data warehouse. And then, yeah, so, and then at some point, it's because we already mentioned it, we have BI tools, which helps then business teams to actually not enjoy that people were processing some kind of data, but in the end, let's say, to pick the data to say, hey, actually, where should we put our sales budget so how we can improve, I don't know, our cost structure in acquisition or whatever. So things that hopefully people do in a business to improve the business at all. And and when we look from here, so where would we place the metric or semantic layer? And we will speak about why we have two terms for that in a second as well. So, but let's say it's called like the metric layer. So, where is it, and what maybe are other parts in between that we should also mention?
So the metric layer fits right on top of the data warehouse.
Mm.
So you've got your source data that can be maybe in some internal data, an internal database. It could be a SaaS tool, maybe your CRM or a
Yeah,
marketing tool, and this is actually we were talking a bit about what's changed. It's so easy to do this now, to centralize
yeah,
all of this third-party data and internal data into one warehouse behind a SQL interface, and that's just unlocked so many benefits down the stack, right? And everyone understands SQL. All the tools read SQL, so it's a great standard for all this to sit on. And the metric layer sits above that. And yeah, I mean, I think we're going to get into exactly what happens, but basically, the metrics layer, you can think of it as it writes templated SQL queries. It's going to write queries for you, but it provides a simpler interface to generate those queries. So you
yeah,
can imagine you go to your metrics there and you say, okay, I want to know a total revenue for last month. I want to know the top products we sold for the last week, or I want to know our cost of acquisition compared to last year. And you don't need to know what are the underlying tables I have to query to do that. You don't need to know how do they join together. What's the foreign key? Like, how do I join users to
Yeah,
my product event data? Like, maybe that's just a user ID, but maybe it's something more complicated than that. But ultimately, a lot of our data stakeholders don't want to know that. And
true.
so the metrics layer kind of removes the idea of joins and tables and group bys and a lot of the technical SQL things that are essential for data professionals, but not for the rest of the organization. So the metrics layer is kind of removing that by writing queries for you.
And how would, or not how would, I mean, it's often like still like this. So how would the world look like when the metrics layer is not here? So in this kind of picture. So
hmm So I think you can add the transform layer,
yeah,
and it's really hard to ignore how much how much more common it is now to handle these transformations with SQL, thanks to technologies like DBT.
yes,
So, so what's happening is people are loading the raw data into their warehouse in the rawest form possible, and then basically writing SQL to clean it up and to join it and to make it look tidy. But then the one step, so I'd say like this is the big difference. So if you're using DBT, and I think a lot of the listeners will be DBT developers and they'll be
yeah,
writing these transform SQL scripts. The big difference is that when you're doing these transformations, you're typically writing them in order to answer maybe a specific question.
yeah,
So here are the daily stats for our users, and you do that by aggregating the underlying event data or the underlying kind of like raw data to a daily level. But what can happen really commonly is that someone says, "Oh, I also need that on a weekly level."
yeah,
Or the finance team wants like a quarterly report, or the product team has just launched a new product, so we need that exact table, but actually for this different feature. And so you basically end up creating new tables
yes,
in the transform layer. There'll be the kind of raw cleaning up. So it's like very technical, clean up the data. There'll be one that maybe joins things together. Sometimes they're
hmm,
called, like staging tables or intermediary tables, which are like you're joining things together and maybe has some transformations in it. And then the final layers are usually taking clean, unaggregated and joined together tables and then aggregating them to answer questions. So you kind of have the top layer tables um, are there to answer specific questions.